Hello, and thank you for joining us for ArcelorMittal's webinar with Automotive Manufacturing Solutions. My name is Gareth Price, and I'm the Assistant Editor here at Automotive Manufacturing Solutions. Today, I'm joined by Cécile Pesci, Product Developer for Coatings and Surface Treatments at ArcelorMittal Global R&D. Today's webinar will examine automotive metallic coatings for cold stamping steels, top performance and environmental protection. To meet their quality and cost challenges, car makers look to select the most suitable and innovative steel coatings. Cécile's presentation will explore innovative steel coatings in the automotive steel industry available for cold stamping and describe the various properties, advantages and typical applications. Before we start, can I remind everyone joining us today to put your questions to Cécile. She'll respond in the Q&A session that follows her presentation. Just type your questions into the box in the lower right-hand side of your screen. If you experience any technical issues during this session, please let us know via the Q&A box and our team will try to fix it. We hope you'll find this webinar stimulating and informative. I'll now hand you over to Cécile for the presentation.
Thank you, Gareth. So good afternoon, everybody. I will go on with the first slide, which is just to remind you exactly what is a metallic coating. So it is a film which is in fact applied on the steel once it has reached its final thickness, so after rolling. The first function of this film is to protect the steel against corrosion. This film can be made of either a pure metal, such as zinc. This is the case for a galvanized coating, a GI. Or it can also be a metal alloy, which is a combination of 2 or 3 of the following compounds: zinc, aluminum, or magnesium. You have here 2 pictures giving example of coatings. On the left, a pure zinc coating, the classical GI. It's a view, a microscopic view in cut of the coating. And on the right, you have the example of Galfan, which is an alloy coating containing 95% of zinc or 5% of and 5% of aluminum. So the coatings can be applied following 3 processes. The first one is electroplating. It is the oldest process to apply a coating. In this process, the zinc layer is bonded to steel thanks to a voltage difference imposed between 2 electrodes. And we have a ionic flux with a saline zinc solution in between the electrodes, and the electrochemical reactions allow the zinc coating to be formed on the surface of the steel. So that is how we apply what is called ZE, the pure zinc electroplated coating. Second way to apply a coating is by hot dip galvanizing. In hot dip galvanizing, as you can see on the drawing, the steel strip is immersed in a molten bath of pure zinc or in a bath of metal plus alloying element, as mentioned before in the case of alloyed coating. At the exit of the bath, the steel surface is wiped and we obtain the required thickness of the coating desired. This is how we apply, we put the coating GI or Extragal in the case of ArcelorMittal products, Ultragal, Galfan, Galvanilde, Alusi and Zanilis, some coatings that we will see afterwards. Please remember that for each coating we need a different bath. So the number of coatings that can be done on one line, on one galvanizing line of a plant is limited. We cannot have a pot of each coating on each line. So this is for the second way to apply a coating. The third way is new. It is a process that has been installed on ArcelorMittal line in 2016, which is called jet vapor deposition. Here we apply pure zinc under vapor form, but this is something that we will see more in detail later in the presentation. So there is various coating in ArcelorMittal offer, and I have classified those coating into the parts they can be applied on the vehicle. First, we have some generic coatings that can be used on all coated parts or almost all coated parts, both for exposed and unexposed. So we have the electroplated coating, the extragal, the galvanized, and the Zanioli surface. For exposed parts only, we recommend the use of ultragal. For unexposed parts, we also have the Zanioli Protect, which is available. And for some specific parts, in specific conditions, we can propose Alusi and Galfan. JetGal will be dedicated to AHSS and fortiform parts of the vehicle. So I would like now to focus on what I would call the first corrosion protection level. In fact, part of the coatings mentioned here are done based on pure zinc, and they bring a first level of corrosion protection compared to bare steel. This is the case of electroplated, extragal, galvanized, ultragal, and jetgal. So let's focus on those coatings. Electroplated coating, as presented already in the processes, is a pure zinc coated, which is applied by electroplating and brings an improved corrosion protection compared to bare steel. It is a coating with which we can decide to apply only on one face, so it is a coating available in monophase. It's available on most of our grades, and the coating thickness can be up to 10 microns. This coating is available for both exposed and unexposed surface qualities, and it's also available if customer wishes with a guaranteed waviness. We will see a little bit later exactly what is waviness. The second coating presented today is galvanized, so it's also a kind of hold coating now. It's containing 90% of zinc and 10% of iron. It's an alloyed coating, so the coating is a mixture of those elements, and it brings an improved corrosion protection compared to bare steel. We are proposing this coating up until 10 microns, and its main characteristics are first an improved spot weldability. You have an increased lifetime of electrodes compared to classical zinc coatings, but it's also harder than zinc coating. So it lowers the friction coefficient, but you could also face more powdering in the stamping shop. Please note that for this coating, the corrosion products are red, so compared to other coatings which corrosion products are white, it can have a negative impact on the image. But this coating is available with exposed and unexposed surface qualities. In ArcelorMittal, the classical product, the GI coating, is called extragal. It's composed of 100% zinc and brings also an improved corrosion protection compared to bare steel. This coating is available up until 25 micron thickness, and it's available for exposed and unexposed surface qualities. On pure GI exposed version, we can propose a guaranteed waviness, and this product will be then called ultragal, and it is this product that I would like to present you more in details now. So first, let's discuss about what is waviness. If we consider the surface of steel, if we consider a piece of steel, if we consider a piece of steel, we can divide the profile of the steel into three kinds of things. First, of course, there is the form of the steel, the macroscopic form, if it is curved, if it is flat, if it is bended. So this is the form that is given to the sheet in the stamping shop. We also have the roughness. The roughness are the micro asperities on the steel, the small peaks and holes that are at the surface of the steel, and that we cannot see by eye. Only if we have a microscope we can see them. And in between, there is in fact a pattern which is called waviness, and which is concerning all the wavelengths between 1 and 10 millimeters. And this is a pattern which can be seen by eye, and which is giving, in fact, the quality of the aspect for a finish after painting. Because when we apply painting on those different level of magnitude, you have the stamped part. You apply painting on it. Okay, you just have to be sure that you have covered and homogeneously covered all the surface, and the paint application will not change the steel form. At the scale of roughness, the paint will fill the asperities, so the roughness will disappear after painting, except if you have a huge roughness, but this is not the case with steel. So the paint will fill the asperities and hide the roughness. But waviness will be maintained after painting, because the paint will follow the waves of the surface and keeps the patterns. So this waviness is the factor that has to be taken into account in order to describe the surface of our product. The steel, before painting, has to be described by its waviness. And I will go further, because it's not only the waviness that has to be taken into account. It's the waviness after stamping. Because in the steel fabrication process, our substrate gains a certain level of waviness all along the process. After temper mill, we are pushing on the surface, so the surface is flattened. We have a flat surface. Waviness is decreased. But when there is a stamping process of the steel, the fact to stamp the surface will push out the waviness, and we will have an increase of waviness after stamping. So this is why ArcelorMittal has designed Ultragal product. It's in order to be able to guarantee a certain level of waviness even after stamping. And this is why the guarantee of Ultragal is given after stamping. So, to be clear, a little bit clearer, what is Ultragal? Where Extragal is a pure zinc coating applied by oil-tip galvanization, we have the level of waviness after deformation is managed, determined at the temper mill. With Ultragal, we are managing all the process parameters all along the line. It's also a pure zinc coating, but we work on process parameters in order to strongly control the waviness level all along the process and be able to guarantee a certain level of waviness after the deformation. And then, once paint is applied on the part, the product appearance is highly improved. So, how exactly do we guarantee the ultragal? We have defined a criteria which is named WA0.8, and it's in fact a waviness determined after measurement on the surface. It's calculated by extracting from the signal measured at the surface only the waviness components between 0.8 and 10 millimeters. So by calculating estimating all those components, we can determine this mathematical number, which is waviness 0.8, and which is measured on what we a Marcignac cup, from the name of the test. It's a cup which is having a plane strain of 3.5% or 5%, depending on the requirements. And we measure on that signal and extract the value of WA 0.8 on steel surface. And in various work, we have shown that the value of the WA 0.8 after stamping is correlated to the quality of the surface after painting. So I've given you here the example of the correlation existing between WA 0.8 after stamping and long wave measurement, which is a typical parameter which is used by our customers to evaluate aspects after painting. And we have a very good correlation between WA 0.8 and long wave parameters. So the lower the WA 0.8, the lower will be the long wave parameter and the better will be the aspect. And we are thus able to correlate WA 0.8 measured on the bare steel after stamping with a parameter after painting on a part. So to summarize everything that I just said on the ID card, kind of ID card of Ultragal. Ultragal is a coating made of 100% zinc, bringing an improved corrosion protection compared to bare steel, equivalent to the one of Extragal. It's available up until 10 micron thickness, and it presents an excellent aspect after stamping and painting. And we especially recommend it when customers are using compact paint processes to support potential switch to compact paint processes. So now let's discuss about another pure zinc coating, but applied in a new way, and which is called JetGal. So JetGal is a pure zinc coating using the new technology, jet vapor deposition, which is in fact a technology of coating under vacuum, which has been developed by ArcelorMittal together with TRM Group. So what are the benefits of jet vapor deposition? First, it is an hydrogen-free coating process. In fact, the coating step is made under vacuum, so we have no contact with water, air, hydrogen, oxygen. So it's a vacuum process. Then it can be used to coat, to apply different metals. So we are currently working with zinc, but other metals can be applied thanks to jet vapor deposition. Then we will see that it is an environmental friendly process, because it has the lowest global warming potential of any coating process. And finally, you will see that it's a coating suitable for any metallurgy, and we intend to apply it on every grade that we need. So first, what is jet vapor deposition? It's pretty simple. We are feeding a system of an evaporator by liquid zinc here. So liquid zinc is brought through a pipe into an evaporator where it's eaten and passing under vapor form. So these devices are available at both sides of the steel strip. Steel strip is passing like that, and the zinc vapor is applied on the surface of the steel strip on both sides under vacuum. So thanks to this process, we have a very high deposition rate, and we are able to run at high strip speed. We can also regulate very well the vapor flow, so the coating weight is very flexible, and we are able to apply such vapor under vacuum on every surface. So all our substrates can be coated this way. So I just put you for illustration some pictures of our line of GVD, which is in Belgium at Liège, Leuven. So you have a picture of the entry of the line on the left. Then we have a degreasing step in order to clean the surface before entering in the vacuum section, which is shown here. So the strip is passing from top to the bottom like that, and it's sprayed with pure zinc in this white box. We have shown in all our tests that the jet gal is an hydrogen-free process. So taking the example of a DP1180, we have measured the content in hydrogen by thermal desorption analysis, and we have compared for such grade the content in hydrogen of an electrogalvanized steel not outgassed, an electrogalvanized steel after outgasing by batch annealing, and the jet gal product. And the content in hydrogen is indicated on the graph on the top left in ppm. So an electrogalvanized DP1180 not outgassed is containing around 0.3 ppm of hydrogen. The jet gal and the electrogalvanized outgassed products are at the detection limit, what we call the noise of the measurement, because we are at 0.05 ppm or under for jet gal, which is a measurement, almost a measurement of the hydrogen in the atmosphere. And when we check this effect by a classical test, which is SCP 1970, where we put a sample of steel under a constraint, and we expect it to be free of cracks due to diffusive hydrogen during several days. If we use an electrogalvanized steel not outgassed, we will have appearance of cracks after a few hours of test. But with outgassed HE and jet gal, we have free of cracks after 1 week of test, where the requirement of the norm is after 4 days. So we have a product which is free of diffusive hydrogen. So we have decided to use this process for the current HSS and UHSS grades, the one more sensitive to hydrogen, that can be for some of them sensitive to hydrogen content, and for the future grades, the one under development. So the grades which are currently available with jet gal coating are all the DPs from DP 450 until DP 1180, the TRIP 780, the martensitic grades, martensite 1200 and 1500, and all the future grades which are in development, such as fortiform grades and martensite 1700. As mentioned before, the jet gal process, the GVD process, is the most environmental friendly coating process. because we have estimated the contribution to global warming of the coating processes. And if we take hot dip coating as a reference, setting that the average contribution is hot dip coating. Electrolytic coating galvanization is contributing twice to the global warming, where jet gal is contributing at around 65% compared to GI. So with jet gal, we are dividing by more than 2 the contribution to global warming compared to electrolytic galvanization. And the DVD technology, the DVD process technology is the greener process for coatings. Now, I would like to focus on the in-use properties of the jet gal coating, because we could be worried that it could behave differently than other coatings. But jet gal is a pure zinc coating. So if you apply 10 microns of zinc, the in-use properties have chances to be the same as with other 10 microns of zinc. And when we compare jet gal performance to electrogalvanized reference, we obtain similar in-use properties as electrogalvanized products. So for protection, temporary protection or protection against corrosion, we have the same resistance for jet gal than for electrogalvanized. And for assembling, spot welding, and stamping, we find the same results for jet gal and for electrogalvanized products. Main difference is really in hydrogen trapping of the process. Jet gal products are free of hydrogen, where electrogalvanized products needs to be outgassed for very high grades. If we compare to a GI reference when available, we have equivalent behavior, except as for the difference between EG and GI, some differences in stamping and in spot welding due to the structure of the coating. So, to summarize my words on jet gal, just remember that it is a 100% zinc coating, which brings an improved corrosion protection compared to bare steel. It will be available up to 10 micron thickness. It can be applied on every steel surface, and we will focus it on AHSS and UHSS grades and all the future grades. It's a nitrogen-free and a green process, and it's equivalent in its use properties to electroplated coating. So, second step of this webinar will focus on coatings with improved corrosion protection. So when I say improved corrosion protection, it's compared to the coatings that I already presented, which are pure zinc coatings. The coatings mentioned in blue here, Vanillis Surface, Vanillis Protect, Alizzi, and Galfan, have specific corrosion protection properties that will be detailed now. So first, Alizzi coating for cold stamping. I'm saying for cold stamping because it is also used for hot stamping grades, but it's not my word here. I will focus on cold stamping. So this coating is composed of 90% of aluminum and 10% of silicium. It's available up until 33 microns, and it has specific properties of resistance to heat. So it will resist to high temperature oxidation and corrosion. And that's why it's a coating that we specifically recommend for parts such as insulating heat shields, engine heat shields, exhaust systems, fuel tanks, diesel filters, machinery casing, and underbody parts. You have a good protection against corrosion, and it's safe for very high temperatures. It will resist up until 660 degrees Celsius and sometimes on specific grades up until 800 degrees Celsius. Other coating dedicated to specific parts is Galfan. Galfan is composed of 95% zinc and 5% aluminum. So such composition of coating brings an improved corrosion protection versus pure zinc coating. It has a better corrosion protection, but also an improved durability. And ArcelorMittal is proposing this coating up until 23 microns. So this coating is recommended for deep drawn parts and the parts requiring a high level of corrosion protection. So electric motors housing, filters and airbag cartridge, window mechanisms, wipers, oil sumps, electronic boxes. So after those two coatings more dedicated to specific parts, I would like to make a highlight on the offer of ArcelorMittal on zinc magnesium coating. So the brand name for zinc magnesium coatings in ArcelorMittal is Zanellis. Up until the end of 2015, ArcelorMittal had one product available called Zanellis, and it was okay with SW022 and Euro norm, with the composition of 3.7% aluminum and 3% magnesium. From now on, this coating will be called Zanellis Protect. Zanellis Protect brings a very high corrosion protection performance. It also has an improved durability versus zinc. It's available for unexposed qualities, and we are proposing it on cold rolled and hot rolled substrates. That means that it is available up until 5mm substrate. But to answer other specifications requiring lower amounts of aluminum and magnesium, ArcelorMittal has developed a new product which is called Zanellis Surface. This product will contain between 1 and 2% of aluminum and 1 and 2% of magnesium. It will bring an improved corrosion protection compared to pure zinc coating. We also have a good durability of the coating. It is already available in unexposed quality and will be available in the coming weeks in exposed quality. So this coating will be available for cold rolled substrates. Let's have a look on the in-use properties of Zanellis coatings. First, they improve the stamping behavior. If we check the friction coefficient of those coatings, which is given on the graphic on the bottom left of this slide, we have drawn the friction coefficient curves for Zanellis Protect, Zanellis Surface, and galvanized steel. We can see that the yellow and red curves are lower than the blue one, which is the one of galvanized coating. So whatever the contact pressure, the friction coefficient of Zanellis coatings are lower than the one of galvanized steel. If we consider the force, resisting force to draw a cup for Zanellis Protect and Surface, we can see on the graph at the bottom right that the force before breaking when we draw a cup like that is higher with Zanellis Protect and Zanellis Surface. So they allow to have higher stamping force and to go further into stamping than with galvanized coating. And the graph on the top right is giving the quantity of powder observed during this test and where a galvanized coating, which has a lot of powdering, I mentioned that before, I don't know if you remember, where a galvanized has a lot of powdering and galvanized and electro-galvanized can have a small amount of particles, Zanilis Protect and Zanilis Surface have very low amounts of particles. We are at zero. We are no amount of particle, in fact. So we really have an improved stamping behavior with Zanilis coating. If we now consider the corrosion protection brought by Zanilis coatings in a VDA, a new VDA test of corrosion, we can see at similar thicknesses. So all the tests here have been made at 7 micron thickness of coatings. We can see that on the left you have a classical GI. After 6 cycles of VDA, a classical GI will already have a lot of red rust. Zanilis Surface will improve a little bit this behavior. We will have a small amount of red rust on the surface. And the Zanilis Protect will improve drastically this behavior with no red rust, almost no red rust, perhaps some points here, but almost no red rust on the sample. If we consider now the cosmetic corrosion resistance, a scratch on the surface, we have a bad behavior of GI coating. We can have appearance of some red rust. We have a slight improvement with Zanilis Surface, and there is almost no delamination with Zanilis Protect. And we also observe those improvements in a stone chipping test with a classical GI, where you can have some delamination of the paint, and it's already better with Zanilis Surface and still improved with Zanilis Protect. So if we classify the protection against corrosion from those 3 coatings, I would say that the best one is Zanilis Protect, a little bit lower Zanilis Surface, and Extragal still a little bit lower at same thicknesses of coating. But for some of our customers, interest can be to substitute and to decrease the thickness of the coating on their parts. That is why I show you these results, which has been obtained with a CT1 corrosion test, comparing GI 10 microns with some Zanilis coatings. So Zanilis Surface ZM70, which is a 5 micron coating, Zanilis Surface ZM90, which is a 7 micron coating, and Zanilis Protect ZM70, which is a 5 micron coating. So we can see on these results, after 12 cycles of corrosion in ECT1 test, that the ZM70 in Zanilis Protect behaves better than Z140, 10 microns in Extragal, and the Zanilis Surface ZM90, 7 microns, behaves the same as a Z140, so Extragal 10 microns. So it can be figured out that 5 microns in Zanilis Protect are suitable to replace GI 10 microns, and 7 microns in Zanilis Surface are suitable to replace 10 microns of pure zinc. I wanted to mention here another advantage of Zanilis Protect because of its unique protection against corrosion. Another application can be figured out, which is replacement of thick GI coatings and post-cataphoresis parts. Because in fact, you will see on those results that if we compare 20 microns of Extragal pure GI coating with 10 microns of Zanilis Protect, we have a better resistance to corrosion after 12 cycles of VDA coating test in perforating corrosion resistance. We also have a better cosmetic corrosion resistance at a 20 microns extragal, and we have very good resistance to stone shipping, at least equivalent to the one of a 20 microns extragal, and perhaps even better. So with replacement of thick GI coating by Zanieli's Protect 10 microns, we ensure the protection against corrosion, but we have also lower coating peeling. We are decreasing the thickness of the coating, so we have a lower peeling, and the welding is easier because of the thinner coating. So, just to summarize on the ID cards of those two coatings, Zanieli's surface, which improves the corrosion protection compared to a pure zinc coating. It's available up to 10 microns and perhaps higher. It's under consult from our customers. We have improved durability thanks to zinc coating. It will be available for expose in the coming weeks. It's already available in unexposed, and it can be used to replace pure zinc with a thinner coating. Zanieli's Protect has an outstanding corrosion protection properties. It has so much that we can recommend it to replace thick GI coatings. It has an improved durability. We are offering the coating thickness up until 25 microns, and it's also available on hot rolled substrates. It will be available for unexposed only, and we recommend it for high corrosion protection. So now, our customers being worldwide, we are trying to have the worldwide offer, and if part of our coating, all of our coating in fact are available in Europe, and we are working to implement those coatings all over the world. So in Europe, all the coatings mentioned here are available. In the United States, we now have GI Ultragal. We also have electroplated coatings, galvanized, Alusi, and Galfan. And we are developing Zanieli's Protect. We are also proposing Ultragal in Brazil, along with galvanized and Alusi. In South Africa, electroplated coatings, and in China, pure GI coatings, galvanized, and Alusi. On the last slide, you will find a summary of what has been presented today, along with the market trends for those different products. So, as mentioned, electroplated coating is the oldest one, so it trends to be replaced by all deep galvanized coating. So, extragal and ultragal being in high development phase, galvanized remaining stable, galfan also remaining stable in consumption, and new developments are a lot focused on zinc magnesium coatings and Alusi coatings, and of course our new product, the JetGal coating. So that's all for my presentation today. So now I will let the word to Gareth.
Thank you, Cécile. We'll start looking at the questions now, but please carry on sending any questions you have. Send them in using the Q&A box. But the first one for you, Cécile. What are the disadvantages of the JVD process, if any?
Concerning the product itself, the JetGal coating, I would say there is no disadvantages because it's a classical pure zinc coating. If there's any disadvantage, it would be more for us because such technology requires a high level of maintenance, and maintenance different than the one we were used to with a deep galvanizing steps, because it's a very high technology equipment.
Okay. The next question is regarding exposed panels. What's the best coating for exposed panels?
For exposed panels, of course, I would recommend the use of Ultragal because it's our best product for premium aspects, thanks to the control of waviness all along the process of Ultragal products. Yeah. We have used it for various applications where some difficulties were existing with the aspects. We have used it also with some customers switching to compact paint processes and which were a little bit disappointed by the aspect of their surface afterwards. And in all cases, the use of Ultragal brings an improvement.
We have a question about the JetGal process. Is there any possibility to use aluminium in the JetGal process?
To use aluminium, to coat with aluminium, or to use the substrate aluminium?
It's not clear from the question. It is.
So I will answer both.
Yeah, it's two ways of looking at it.
Use of aluminium as a coating can be figured out with jet vapor deposition, of course. It's an adaptation which is required because it has to be at a very, very high temperature because we have to vaporize the product. So, of course, it's not transferable very easily, but I guess that it can be figured out. Second question in the question would be use aluminum as a substrate in the JetGal process, and as any surface can be coated with jet vapor deposition, I would say yes, it's possible to coat aluminum with GVD.
Okay, thanks. What about CP steel grades? What's your approach there?
What about CP with JetGal?
Well, across all of any of the suitable coatings.
So CP steel grades can be coated as the other ones. So we work to coat. So they exist with GI coatings. They already exist with GI coatings. And we've also worked to apply JetGal coatings and zinc magnesium coatings on them. We are trying to extend our offer of coatings to all of our grades. But not in Ultragal. I think it would not be necessary for exposed panels.
Okay. Regarding the slide on the evaluating the contribution to global warming, how is that evaluation done regarding the different coating processes?
So, in fact, we have an evaluation for our product of life cycle analysis. And for the different ArcelorMittal products, we are evaluating different indicators, such as this one, because we make the life cycle and we study the consumption in energy, in fossil energy, in water consumption, etc., etc. We take into account all the contributions to global warming of a process, and we evaluate the contribution of each process to global warming. And we set a reference, of course, because you need to have a reference. And we compare the other processes, such as electrolytic galvanization and and jet gal for coatings, and we check what is the contribution of the other one. So will jet gal consume more water or energy than other processes? No, because it's a brand new technology which is not using water and consuming less energy than the other one. And that's how the global warming indicator is evaluated.
Okay, thanks. The next question is regarding Zagnalis. Does Zagnalis perform better than conventional zinc for unprotected stamped edges?
For unprotected stamp edges? Yes, this is the question. So for unprotected stamp edges, there is, in fact, an optimum ratio to have between the coating thickness and the substrate thickness. The higher the thickness of the edge to reprotect, the higher zinc magnesium coating thickness you will have to get. But yes, especially with Zagnalis Protect, we have an effect of reprotection of the uncoated edges, thanks to the thickness of the coating, which will form, in fact, protecting compounds on the edges of the steel. So if I have the information from the person who has that, I can then show him or her some results about that.
Absolutely. All of the questions that the listeners are sending in will forward to you, Cécile. Yes, so also if you don't hear your question answered, as we've said, Cécile will receive the questions and also your contact details to give you a response in greater detail than we can here on the spot. A couple more questions about Zagnalis. A question is asked, what about weldability of the various Zagnalis coatings? Apparently this used to be a major concern.
Yes, I understand, because it's true, I could not get into all the properties that Zagnalis coatings and all zinc magnesium coatings in general have a lower electrode life than pure zinc coating. It's not a lot, but I think that electrode lifetime is decreased by something like 20% to 30% compared to a classical GI, according to normalized tests, such as ISO or SEP. But then I would say that it's highly related to the policy of the customer concerning electrode maintenance. For some customers which are not doing a lot of maintenance on their electrodes, they will see a difference. If they have a policy of very frequent electrode maintenance, they won't see a difference. And then I have to remind that normalized tests are linked to use of zinc magnesium for all parts. And I think that for now, at our customers, zinc magnesium is not yet on all the vehicles, on all the parts of the vehicle. So it's a balance to find for electrode maintenance.
Okay, and the question about JetGal once again. How uniform is the coating in the JetGal deposition?
So we are making the statistic, as it is a very new process, but we managed to get a very uniform coating thanks to this application. I would say that it's around, it fits all the specifications of the customers, because I think we can reach up until plus or minus 0.5 microns along the length and the width of the product. There is a very good flexibility of the vaporization and the application of the coating. So it's a very accurate process.
We just have time for a couple more, but and I think you might have mentioned this in your presentation. A question is asking, is the JVD coating now commercially available?
Yes, it's commercially available, and we can deliver all the substrates mentioned with the JetGal coating. Yes.
Okay, and just finally, a more general question, really. How much progress has the steel industry made regarding the corrosion protection issue over the years? And will progress continue at a similar speed?
I would say, do we need more corrosion protection? Because we already have very thin coatings able to provide an excellent corrosion protection. When you see that with the Zanilis Protect of 5 microns, you can last hours and hours in accelerated corrosion tests. We have reached an excellent level of corrosion protection. I think we will never see again cars when the parts are coated with red rust on them. So perhaps that we can still improve corrosion protection, but also we could work on other in-use properties now. Why I focus today my webinar on the corrosion protection, but from now on we could also imagine coatings for other in-use properties, improving the stamping, improving the welding. There is a lot more to discover, and that's good for us.
Yes, absolutely. Thank you very much for joining us today, and thank you to Cécile for a very informative webinar. The webinar will be uploaded onto the AMS archives and accessible in future for all of your colleagues who've been unable to join us for the live presentation. You can access this and all of our previous webinars via the webinar tab at the AMS homepage. We'd like to get your feedback on the webinar, so there's a short survey coming up. Please take time to complete this, as we very much appreciate your input. Thanks again for taking part with us today, and we hope you'll join us again for our next webinar. Goodbye.